Hello, in this video, we're going to learn how to find the eigenvalue and eigenvector of a metric. So this is an example of a 2 by 2 matrix, and we'll do it in 2 steps. In step 1, we'll find the eigenvalue, and in step 2, we'll find the eigenvector. So we say let lambda be the eigenvalue of the given problem, and step 1 is we find lambda times the identity matrix. So now if lambda is multiplied to a matrix, let lambda be a scalar, then we will get lambda 0, 0, lambda. This is because the identity matrix is 1, 0, 0, 1. So if you multiply this with lambda, all elements get multiplied by lambda, so we get that. And then we say let this matrix be A. So then we find A minus lambda I. So we take this matrix and subtract it from this matrix. So each element gets subtracted individually. So we get 0.8 minus lambda, 0.3 minus 0, which is 0.3. Then 0.2 minus 0 is 0.2. And 0.7 minus lambda. So first we find lambda I, then A minus lambda I. Then the next step is to find the determinant of A minus lambda I. So we find the determinant of this matrix. It's a 2 by 2 matrix. All you have to do is cross multiply AD minus BC. So you get 0.8 minus lambda times 0.7 minus lambda minus 0.3 times 0.2, 0.3 times 0.2. So this is the determinant of that matrix. Now you can simplify this by simplifying this brackets and multiplying these two, and then factorizing. This will end up in a quadratic equation, which you will have to factorize. Now, if you don't know how to factorize, you can use the quadratic formula, or you can look at another video of how to factorize the quadratic equation. So once you simplify this, you end up with this quadratic equation. This is lambda square minus 3 over 2 lambda plus 1 over 2. And then you factorize this, it becomes lambda minus 1 bracket lambda minus half. And then you make it equal to 0 and solve for lambda. So we get lambda equals 1 and lambda equals half. And these two are the eigenvalues of the given matrix A. Okay, so in step 1, we find the eigenvalue, and these are the steps. Even if it's a 3 by 3 matrix, you can do it the same way. Find lambda I, A minus lambda I, determinant of that, make it equal to 0 and solve for lambda. Okay, so this was finding the eigenvalue. Now in step 2, we'll find the eigenvector. So let me delete this. Step 2, it would be to find the eigenvector. Okay, to find the eigenvector, what we need to do is, for each lambda that we got, so say lambda equals 1, we have to solve the equation AX equals lambda x. Okay, so in place of lambda, you plug in 1, where x is the eigenvector. Now, since this is a 2 by 2 matrix, x will be column vector x1, x2. Okay, so the matrix was 0.8, 0.3, 0.2, 0.7. Multiply that with x1, x2. In place of lambda, you put 1, so you get 1 times x1, x2, which will just be x1, x2. Okay, now simplify the left-hand side and make it equal to the right-hand side. We get 0.8x1 plus 0.3x2. Right, if you multiply this row with that column, let's put it in the matrix for now. And the right-hand side is still x1, x2. And multiply the second row with the column, you get 0.2x1 plus 0.7x2. Now we equate the first term with the first term, equate the second term with the second term. You get, let me delete this, 0.8x1. We're equating the first term, 3x2 equals x1. So now bring the x1s on one side and the x2s on the other side. We get this is 0.3x2. So 0.3x2 equals x1 minus 0.8x1 will be 0.2x1. So you can divide by 0.2 on both sides. We get 3/2 x2 equals x1 if you divide by 0.2 on both sides. Okay, so this is a relationship between the two values of the eigenvector. If you do the second row as well, you'll get the same thing. So we should say let x2 be 1, just to make life easier. So if x2 is 1, x1 becomes 3/2. In place of x2, you plug in 1, x1 becomes 3/2. So of eigenvector x will be 3/2 and 1. Now just a note here, if you're doing a game theory problem of Markov chains, x1 plus x2 will have to be equal to 1. So that'll be an extra condition when you do that. And in that case, these guys will be decimals that add up to 1. Okay, so just be careful about that. And then you continue the process for lambda equals half. So this is your first eigenvector, capital X1. And you continue the same thing. You can check this the same way, ax equals lambda x, and you should get the second eigenvector to be 1 minus 1. Okay, so 2 eigenvalues and 2 eigenvectors for the given problem. This is how you find the eigenvalue and eigenvectors for a given matrix A. Hope this helped. If any questions, you can put it below.